We meet again, anatomy, you and me, talking about part 3. So we're going to go over to the levels of organization before we can actually hit the main topic today. So again, we have chemicals and molecules combined to create cells, those combine to create tissues, those combine to create organs, and those combine to create organ systems, all different kinds. Yes, you will need to know them. Then they combine to create the organism. Everything works together and is connected together. And why, you ask? To maintain homeostasis. Homeostasis is an internal environment that is stable in a changing world. Homeostasis, homeo meaning same, stasis meaning unchanging. It involves 3 big pieces. A receptor to sense the stimulus, a control center to receive and process the information from the receptor, and an effector that actually responds to the commands from the control center. Now this effector can do one or two things. It can oppose the stimulus, or it can reinforce the stimulus. Now what exactly does that mean? So with types of feedback, we have a negative feedback in which the response or the effector decreases the original stimulus. This is most common. You see this when we talk about body temperature, shivering and sweating, blood glucose levels, our heart rate, our pupil dilation. The stimulus goes one way and we're trying to get it back under control going the opposite way. Now, our other type of feedback is going to be positive feedback. The response of the system enhances the original stimulus or increases the activity, such as birth contractions and blood clotting. So let's take a temperature of the room. If the temperature goes up, the thermometer will receive it as the receptor. It will inform the thermostat. The thermostat then sends out a command to the effector or the air conditioning to turn on. The air conditioning turning on drops the temperature. So the stimulus wants to increase the temperature, is increasing the temperature. The thermometer, the control center, decreases the temperature. That's going to be negative feedback. Let's take a human example. So our body temperature is rising. Our body temperature sensors actually receive that information and send it to the thermoregulator in our brain. We process it, and the thermoregulator center sends out a message to the blood vessels and the sweat glands, which are going to be our effectors. And these guys increase blood flow to the skin. This increases sweating, thus removing the stimuli and restoring homeostasis, which is our main goal. So the temperature was rising, we're trying to bring it down. That's again going to be negative feedback. What happens if it's the reverse? Our body's temperature decreases. Well, it's almost the same thing. Our temperature sensor sense it sends it to the thermoregulator. The thermoregulator sends a command to the blood vessels and the sweat glands in the skin and the muscles. There's an added feature there. Now, it decreases the blood flow, decreases sweating, and the muscles shiver, creating heat, thus increasing our body temperature, thus removing the stimulus and restoring homeostasis. So it was causing our body to drop. We were trying to increase it. Again, negative feedback. Homeostasis, a homeostatic control mechanism. 2 primary systems. We have the nervous system that is in our control mechanism and the endocrine system. Again, we have the 3 components, which are the receptor, the control center, and the effector. Looking at this diagram, that just disappeared for some reason. Okay, looking at this diagram, we have homeostasis and balance. But when a stimuli changes the variables, it causes it to go out of balance. Changes is detected by the receptor, The information is sent along to the control center. The control center sends information to the effector. The effector has a response that either feeds the stimulus or decreases the stimulus, therefore returning it to homeostasis. So let's try a few. You go outside, it's hot, you sweat, you feel cooler. The stimulus is the heat. Your effector causes you to sweat, and you feel cooler. So increasing temperature, you're trying to feel cooler, which is decreasing the temperature. This is going to be negative feedback. Okay, so you cut yourself, and you have platelets migrate to the cut to begin plugging the cut, and then you also release blood clotting factors that also cause the blood to coagulate and clot. So we have trying to clot, and then we're adding more to try to clot some more. So we're increasing the stimuli, which is going to be what type of effect or feedback? Positive. Are you positive? Next, we eat lunch, your blood glucose levels begin to rise. Your pancreas releases insulin, and the insulin is sweeps the glucose out of your blood. So, glucose levels rise, you're trying to get glucose levels down. That's going to be what kind of feedback? Negative feedback. Finally, last one. You are having a baby. The pressure of the baby's head against the sensor near the opening of the uterus stimulates the uterine contractions. These contractions cause great pressure against the uterine opening, which heightens the contractions, causing still a greater pressure, therefore more contractions. So we have contractions, and our overall effector is adding more contractions. So what kind of feedback is that? Positive feedback. Now, ladies and gentlemen, I've gone over these types of questions in my video. These are very good types to look at and study for your test. Homeostatic disturbances. What can cause a disturbance in homeostasis? Well, disease, which is a pathological process with a defined set of characteristics, in which a part or all of the body cannot carry out its normal functions, i.e., or a part or all of the body cannot maintain homeostasis. So, if it's locally, it's only going to affect a limited region, such as cancer. If it's systemic, it's going to infect the entire body, such as HIV, leukemia, and autoimmune diseases. So again, looking at this mechanism, we want homeostasis to stay in balance. When it's out of whack, our receptors receive the information, send it on to our control centers, they decide what to do, tell the effectors, and the effectors either decrease the stimulus or increase the stimulus, therefore maintaining homeostasis. That's all I got for you today. Have a good night.